Thank you so much, and welcome. So yeah, my name is Anton Krupskyi. I'm security consultant at Accenture, and today I would like to walk you through public key infrastructure and one of the interesting projects which I was part of. But before, I would like to understand your background a bit. So how many of you know what exactly does the green lock means in your address bar in the browser? And how many of you got exceptions and clicked yes, ignore it? So today I would like to explain a bit what is going on behind that and how can we solve it. So it was my pleasure to be part of a very interesting project at the German telecom provider. So I would walk you through the problem of issuing certificates in the dynamic environment, the solution that we proposed, and the details of implementation that we have done throughout this project. So a little bit of the background. Client had multiple regions covered, with each of them having a separate network based on the hardware, by multiple individual services in each of them, like 650 platforms, which was really hard to manage. So what I decided to do to migrate to unified network, which would be cloud-based, agile, scalable, and implement something like infrastructure as a code. So now you see the problem when you need to manage certificates in the environment, which is highly dynamic. Yeah, to improve security of such solution, we are going to implement end-to-end encryption, and here is why. It's not a secret that traffic can be intercepted, and there are multiple tools available in the market for that. And also, there was a nice case with Google where they assumed that, yes, at the front end they have enabled TLS and they're secure, and the rest of the communication within the secure perimeter is not encrypted. But what happens if that perimeter is being penetrated? So solution for this is public key infrastructure, which allows us end-to-end encryption with the highly secure protocols. So let's go further and see how to implement it. But before, I would like to just again walk you a bit through what exactly is PKI. So it is based on two principles. One is asymmetric encryption, and the other one is the trust. So asymmetric encryption means that there are two keys bound mathematically. One is used to encrypt, the other one is used to decrypt. So the public part of the key will be published, so each party can access it, and the private key will stay with each party. So this can be viewed as a mailbox with the key where everybody can drop a message, but only the owner can get it. So another aspect is the trust. So this means that the public key issued by the authority, which does the identity verification prior to that, and everybody trusts that authority. So this can be viewed as a mailbox with the ID on it, so that you know exactly to whom you are submitting the message. Now, why do we need a certificate authority? So yes, when two parties start communicating, they exchange their public keys so that they can encrypt the messages. But what happens if somebody will be there in the middle? It will provide public key on behalf of the other party, and he will be able to get the communication from one side, decrypt it, re-encrypt it with the other side, and send the message back without both the parties even not knowing that somebody is there in the middle. For that, we have an authority that will sign the keys, and this way, when you get a public key, you can verify. So since you trust the authority, you trust the key that you have received. So this way, man-in-the-middle attack will not be possible. Now, the challenge in dynamic cloud environment is following. When you would like to have public key infrastructure enabled and certificates issued, this is a manual process where humans are involved to verify the identity. Imagine if thousands of services are coming up instantly and you need to serve all of them, plus you also have renewal period. And what if your security department says that we want to have validity of those certificates for weeks, not months? And so imagine how many people you need to handle all that. So I have a solution for that. So what if we have a certificate authority that will be able to work automatically and issue certificates in response to the client's request? And what if we have an agent that will be able to verify an identity and respond to the challenge, and also will be able to handle the life cycle of the certificate automatically, and for instance, renew it on a regular basis. So there is an ACME protocol. It is developed by Let's Encrypt research group. Their aim was to increase HTTPS usage over internet to secure the communication. It enables automated certificate requests, identity verification, and lifecycle management. And the best part about it is it doesn't compromise security, because there is a way to verify the requester's identity. Let's Encrypt BOULDERCA and Cerbot are Let's Encrypt implementation for ACME protocol. So what happens? Cerbot will request the certificate. BOULDERCA in turn will send a challenge. Then Cerbot has to verify his identity by providing the challenge response. And then when this is satisfied, BOULDERCA will issue certificates. So a bit in details how the challenge works. A challenge is a random string which is being sent in response to the request. And then the string is being retrieved by making a query via DNS record, which has been claimed in the request. So there are three ways to return back this secure string. So one is TLS SNI challenge. So a client will raise an ad hoc server, will provide self-signed certificate where the string will be included as one of the parameters. Another challenge is HTTP. HTTP challenge, where client will be able to place a file with the challenge on the web server, and certificate authority will be able to retrieve that. And DNS challenge, where client will be able to place a text record on the DNS, and certificate authority will be able to verify that. So what you get, once you have this all in place, you have authority which automatically issues certificate in a dynamic environment. You have the client which is able to automatically do the request, will be able to verify, provide the verification of the identity, and automatically manage the life cycle of the certificate. So now coming back to our client. We have multiple use cases identified. Of course, First one is automated PKI infrastructure, which will be handled by BOULDERCA. There is also manual certificates in case, for some reason, it is not possible to automate or, like, for instance, install the client. And there are also use cases for user certificate to authenticate, for endpoints, and for smart cards, for instance, for physical access. So we have developed the tree of certification, where on the top the process is manual and it gets automated on the bottom. So as you can see, the BOULDER CA is a part of infrastructure CA, along with the manual CA, but now I would like to zoom in into BOULDER CA and showcase how it is being built. So initially, it's an open source provided as a container. So we decomposed it, built it in a cluster behind the load balancer. So the solution itself is stateless. Therefore, there is no need to do a sticky session or something. We can just have simple round robin, so every request can go to every instance, which is having a connection to the backend, where all the information about requests, certificates issued, and things like that are stored. So in our case, it's MariaDB on Galera cluster. And zooming in further, as you can see, BOULDERCA is a microservice-based solution. Communication between components happens using RabbitMQ. However, you can tweak it into a simple HTTP or HTTPS communication and split it even further to different servers based on, for instance, the load of each component. So if we zoom in a bit further and see what are the components, so there is a servbot sending requests to web frontend. Then there is a registration authority which checks whether the request has been already received previously from the same client. Then there is a certificate authority which will actually sign the certificate, and that is backed up by SoftHSM, which actually has the private key to sign the certificate and send it to the client. And as you can see, once again at the backend there is a MariaDB where all the information is being stored. So just a quick overview. Our solution was built totally on open source. So as you can see, for for server provisioning and configuration, there is Terraform and Ansible. For the software that we used, for instance, there is a Vault to store our secrets. There is MariaDB as a backend solution. There is HA proxy to load balance our requests. Yes, there was also GitLab involved in that, where based on containers, Docker runners are being involved. And of course, there is Servbot and Let's Encrypt BOULDERCA. So before concluding, I would like to once again thank you, the team, which was working on this project. So despite of the fact that we were coming from different locations, we were able to integrate very much, bring all the necessary skill set to the table. And also we were working with the client team as a whole, and we made this project a success. So if this rings a bell, and if you're interested in this topic, please feel free to get in touch with me. Oh. Thank you so much.
Okay, thank you very much, Anton. Thank you.